Welcome to the third video on the thin pressure vessel, and this time we are going to find out the shear stress in the two-dimensional plane of a stress and three-dimensional of a stress using the Mohr circle method. So we discuss here the two-dimensional Mohr circle for the thin pressure vessel, and then I will introduce you the three-dimensional Mohr circle for the pressure vessel. As you are familiar, the Mohr circle is a graphical method used to represent the state of a stress of a material or structure under a certain load condition, and the circle is used to determine the principal stresses, maximum shear stress, and the orientation of the plane on which the stress will act. The horizontal axis here represent the normal stress, which is represented by sigma. So both the stresses here, that is the longitudinal stress and the hoof stress, can be shown on the x-axis, that is the horizontal axis. On the right hand side, we will show the positive value of a normal stress. On the left hand side, we will show the negative value of a normal stress. Y-axis represents here the shear, that equal to tau. The positive vertical axis represents the shear stress, which is having a clockwise rotation, and the negative vertical axis represents here the shear stress in an anti-clockwise rotation. In the plane state of a stress, we have to show here the longitudinal stress and the hoof stress. This time we have hoof stress is equal to 2 times of longitudinal stress. So highest value we can mark here is equal to hoof stress. So let mark here the distance equal to sigma h, and the corresponding point here represent the maximum normal stress, that equal to sigma 1 is same as equal to sigma h. There is no shear stress acting either on the x plane or y plane, so we have hoof stress is same as the maximum normal stress. Second stress we can represent here the longitudinal stress, which one is exactly half. So we have sigma L will be equal to sigma h divided by 2. So this point will represent here, that is equal to sigma 2, and the value of sigma 2 is same as equal to sigma L, and this value of sigma h will be equal to 2 times of sigma L. So if I know the point A and the point B, I can join the point A and B, and exactly the halfway we can mark here the center of the Mohr circle. Here we have sigma h is equal to 2 times of sigma L. Already we have marked the distance equal to sigma L. It means that sigma L is divided into 2 equal parts. So this distance is same as sigma L divided by 2, as well as this distance also sigma L by 2. So coordinate of center from origin O will be sigma L plus sigma L by 2, and the radius of the circle is same as sigma L by 2. See, at the center here we will draw here one circle, that one represent the Mohr circle in a plane stress. So this one is representing the Mohr circle in the case of two-dimensional state of a stress. The corresponding value on the shear stress will represent here the maximum shear in plane. So in this case we have value of the normal stress. Maximum is sigma 1 is same as equal to the hoof stress, that is given by pressure multiplied by internal diameter d divided by 2 times the thickness of the wall. Then we have minimum principal stress, or minimum value of a normal stress is given by longitudinal stress sigma L, which is given by pressure multiplied by diameter d divided by 4 times the thickness of the wall. And the maximum value of a shear in plane is the radius, and this time we have radius equal to sigma L by 2. So we have sigma L by 2. Sigma L by 2 is same as the pressure multiplied by diameter divided by 4 into 2, that will be 8 times of T. So this one is representing the maximum shear in plane. Here the point D and the point E represents the maximum shear, and this angle is 90, that equal to 2 times of theta s. It means that we have maximum shear will occur at 45. So plane of maximum shear will be equal to theta s. We have theta s is equal to 45 degree. So this state of a stress you have to rotate by an angle of 45 degree, then we can show here the maximum shear. So if I rotate it by 45 degree, I will get this state of a stress, and this state of a stress will show the maximum value of a shear stress. And on this plane right now we have the stresses are also acting, that is the stress acting will be equal to sigma L plus sigma L by 2. So you have to show that stress also. So what normal stress you have to show, that will be equal to 3 times of sigma L divided by 2. And other you have to show on the y plane, which are the same magnitude, that equal to 3 sigma L by 2. In the case of a three-dimensional Mohr circle for the thin pressure vessel, the horizontal axis represent here the three principal stresses, that equal to the longitudinal stress equal to sigma x. Then we have the hoop stress, that equal to sigma h, and one radial stress, that equal to sigma z equal to 0. So we can mark here the value of sigma h. Now sigma h here is 2 times of sigma L. So let's say here point A represents here the value of sigma h, and this value of sigma h equal to 2 times of sigma L. So this distance from origin to A is equal to 2 times of sigma L. Then second stress is sigma L, which is half of the hoop stress. So let's mark here OB, that equal to sigma L, and sigma L will assign as per the order as a sigma 2 value, and this one is a higher value, that will be equal to sigma 1. So sigma 1 represent here the maximum value of a normal stress, sigma 2 represent here the intermediate value, and the third value here, that is the radial stress, will assign equal to 0. So in this case we have sigma 3 will be equal to 0. So we can draw here one more circle corresponding to sigma 1 and sigma 2. Now this distance will be same as equal to sigma L, and this distance also equal to sigma L. Second Mohr circle we can draw for sigma 2 and sigma 3, and the third Mohr circle we can draw for sigma 1 and sigma 3. So this Mohr circle is drawn for sigma 1 and sigma 2. Then second Mohr circle will draw for sigma 2 and sigma 3. Now O to B is same distance equal to B to A. It means that we have same size of Mohr circle will form for sigma 2 and sigma 3. So this one is the second Mohr circle is drawn for sigma 2 and sigma 3. And one larger Mohr circle you have to draw for A to O between sigma 1 and sigma 3. So this Mohr circle represent between sigma 1 and sigma 3. And it has a diameter equal to same as equal to sigma h is same as equal to 2 times sigma L. So this diameter D will be equal to 2 times of the longitudinal stress sigma L. Therefore radius equal to sigma L. Corresponding to this larger size of the Mohr circle, we have tau max, and this one is called as absolute value. That is the largest value among all the Mohr circle, and this value is same as equal to the radius of a Mohr circle, and the radius of the Mohr circle is same as sigma L, that is the longitudinal stress. So as far as the maximum shear but absolute value is considered, the absolute value of a maximum shear is equal to sigma L, which is same as equal to P multiplied by D divided by 4 times of T, whereas the maximum shear in plane will be PD divided by 8T. You have to remember tau max in plane and tau max absolute, because this one is a objective questions. In all competitive exams you will always get a question based on the maximum shear in plane and the absolute maximum shear. This question we are taking from the 2015 GATE exam. A cylindrical tank with a closed end is filled with a compressed air. It means that your pressure is uniform and is given as 500 kilopascal. Inner radius of the tank is 2 meter. It has a wall thickness equal to 10 mm. The magnitude of the maximum in-plane shear, very clearly mentioned in-plane shear. In-plane shear means that we have to show the maximum principal stress and the minimum principal stress, and only the Mohr circle you have to draw for two-dimensional state of a stress. So we'll represent here the two-dimensional state of a stress. Longitudinal stress is sigma L is a lower value as compared to the sigma H. So sigma H will assign as a value equal to maximum normal stress. Sigma L will assign equal to sigma 2. We know that the sigma H is 2 times of sigma L. As far as sigma 1 is considered, we have sigma 1 is same as equal to the hoop stress is same as equal to pressure multiplied by diameter D divided by 2 times of wall thickness, Pressure you have to take in megapascal. This time we have given the kilopascal, that will be equal to 0.5 megapascal. Multiplied diameter here, diameter is equal to 2 times of radius. So that will be equal to 4 meter is equal to 4000 and is divided by 2 times the thickness, and we have given the thickness equal to 10 mm. So we have 2000 divided by 20, that will be equal to 100. So we have value of sigma 1 will be equal to 100 megapascal. In this case, we have sigma 2 will be equal to the longitudinal stress is same as equal to the hoop stress divided by 2. 100 by 2 will be equal to 50 megapascal. So we are ready with the two principal stresses, sigma 1 and sigma 2. So let's draw here the normal stress and the shear stress axis to represent the Mohr circle in two-dimension state of a stress, that is the plane stress. Let O represents here the origin. First we mark here sigma 1 which is equal to 100 megapascal. 100 megapascal will be somewhere here. So let this value is equal to sigma 1 is equal to 100 megapascal. Then we have sigma L will be equal to 50 megapascal. 50 megapascal is exactly halfway. So this point represent here the point A. Point B represents the value of sigma L. And we have sigma L is equal to 50 megapascal. Sigma 1 and sigma 2, that is sigma L, we can draw here one Mohr circle. So this Mohr circle is a diameter equal to AB. So diameter in this case will be equal to 100 minus 50. That will be equal to 50 megapascal. And this value corresponds to the maximum shear in plane. So this one is tau max in plane is same as equal to radius r, and the radius r will be same as equal to 25 megapascal. So the required answer in this case is 25 megapascal. Take another numerical here from again GATE 2015. A gas is stored in a cylindrical tank of inner radius equal to 7 meter, wall thickness equal to 50 mm. Gauge pressure of the gas is 2 megapascal. We have to always use the gauge pressure. Maximum shear stress. Now nowhere it is mentioned here that it is a plane. So we have to find out here absolute maximum shear. So again we have to first calculate here what is the hoop stress, then we have to calculate the longitudinal stress, and the third stress you have to make it equal to 0. And then you have to draw here the Mohr circle corresponding to the maximum and the minimum value of the principal stresses. So this figure here again representing the two-dimensional state of a stress. We have to convert the two-dimensional state of a stress into three-dimensional state of a stress. Out of sigma h and sigma L, sigma h is a higher value. So you have to always arrange the stresses in increasing order. So highest value will assign equal to sigma 1 to sigma h, sigma 2 equal to sigma L, and the third stress will be equal to 0. Whenever you have to convert the two-dimensional into the three-dimensional, sigma 3 you have to assign equal to 0. In this case, surely here we have sigma 1 is greater than equal to sigma 2 is greater than equal to sigma 3. Strictly you have to follow this order. Out of this we have sigma 1 will be same as equal to the hoop stress, that is the sigma h, and sigma h is given as pressure multiplied by diameter divided by 2 times the wall thickness T. Pressure here is again given as a gauge pressure is 2 megapascal. So we have 2 megapascal. Diameter will be 2 times of the radius, that is equal to 14 is 14 into 10 to the power 3 divided by 2 times of wall thickness, thickness equal to 50. So we get the value of sigma 1 is equal to 280 megapascal. Now this 280 megapascal is same as sigma h, and therefore we have sigma 2 will be equal to sigma L is half of the hoop stress. 280 divided by 2 will be equal to 140 megapascal. So let's draw here the axis system. Horizontal axis represents sigma, vertical axis represents the shear stress. Maximum value of a principal stress is equal to 280. So let's mark here the point A, which is representing the value of sigma 1, that equal to 280 megapascal. Then we have sigma 2 is equal to 140. So let's mark here another point exactly halfway, This is representing the value of sigma 2, that will be equal to 140 megapascal. And the third value you have to mark equal to sigma 3, that will be equal to 0. Maximum Mohs circle is possible for sigma 1 and sigma 3. So this one is the maximum possible Mohs circle. One Mohs circle we can draw from A to B, but it is a smaller Mohs circle. Another Mohs circle you can draw for sigma 2 and sigma 3. So we'll consider this Mohs circle for sigma 1 and sigma 3. The diameter of this Mohs circle is equal to D is same as equal to sigma 1 is equal to 280 megapascal. And this value represents here that value of tau max. Value of tau max is same as the radius r. So we have maximum shear, that is the absolute value, because we have taken the principal stresses sigma 1 and sigma 2. So we have maximum absolute shear will be equal to the radius r, which one is diameter divided by 2. That is, we have 280 divided by 2 is equal to 140 megapascal. Check here whether he is interested in the maximum shear stress or he is interested in a maximum in-plane shear stress. That makes a difference. In the case of maximum in-plane shear, you have to consider sigma 1 and sigma 2. And in case of maximum shear, you have to consider sigma 1 and sigma 3. So using sigma 1 and sigma 3, we can calculate the maximum shear. And we get this answer is exactly equal to 140 megapascal, which one is nothing but the radius. So this time we have radius r is equal to 140 megapascal. The video you are watching is from the app, which is the Mohod class app available on Google Store. And in this app, we'll cover all subjects involved in mechanical engineering for GATE. Join the course directly from your mobile. The link is given here.